Hello, welcome to this clip having a look at how you can recognize monomer units in a polyamide chain. I'm going to use a simple question example at the end. But first of all, let's just review what a polyamide is. It's a condensation polymer formed by the reaction of a carboxylic acid end of one monomer with the amine group of end of another. And the two monomers can be the same or different. The amide link is formed between monomers as a result of this reaction, causing a water molecule to be eliminated, and the repetition of this linkage is called the repeat unit. So in this example, we've got an amino acid, and you can see it's got an amine end and a carboxylic acid end. So what that means is when you draw the repeat unit, you have to make sure that the trailing bond on one side is from the carboxylic acid, and the trailing bond on the other side is from the amine. So if we look at a common example used in exam questions such as nylon 6,6, the amide link is in the middle. You can put square brackets, but they're not essential. But you need to put the trailing bond from the amine on one side and the trailing bond from the carboxylic acid on the other. So looking at the monomers that would be used to make this, you'd have hexane 1,6-diamine for one side and hexane dioric acid on the other side. So where do those particular number of carbons come from? Well, if we count them up, you've got 6 carbons here, so 1, 2, 3, 4, 5, 6. And over on the right hand side you've got 1, 2, 3, 4, 5, 6. So just to double check on that, 4 CH2s is 4 carbons here, 5th carbon, 6th carbon. So 1, 2, 3, 4, 5, 6. So what happens in the reaction to make the amide link is you put those two monomers next to each other, and the amine on one and the carboxylic acid on the other will react to make the amide link, and it will eliminate a water molecule. Now in this particular case you can also make nylon using hexane diaryl chloride, so an acyl chloride. So the same thing happens, except this time an HCl molecule is eliminated, not a water molecule. Now, as you can probably guess, that causes problems because HCl is toxic and it's also corrosive. So this is not the preferred way of making it. It works, but the preferred way of making nylon is the previous slide, not this particular one. So let's look at our exam question example. So it says wool is a protein. It's a natural polymer made by the same type of polymerization as nylon 6,6. So the first thing to do is to spot the repeating amide link. There's 3 of them here. So now we need to think about how many monomer units does this section contain. So the thing to do is to look for where the amide link breaks in between the carbon and the nitrogen. And you can apply that little boundary across here and see that you've got 4 different monomers. So therefore there's 4 monomer units in this section. Okay, thanks for listening. Until next time, see you soon.